Hi, today we're going to try and install the Git utility required to download the application, RStudio. So first of all, we need Git, and the first thing we need is a terminal. Well, if we try this, let's see how this works. An hour and 55 minutes. There's quite a lot of information coming down here. Oh, 2 minutes. Well, that's not so bad. Let's open another window and see how fast things are coming in. So this is number of bytes every 10 seconds. Oh, it was downloading, now it's installing. If you're on an earlier version of Mac OS and this doesn't work for downloading Git by just trying it, as I just showed you, then you should go to the website brew.sh, brew.sh, and install Homebrew, and then do brew install Git. So let's go to rstudio.com. There we are. We have products. RStudio is the thing we want. And there's a desktop version. That's the one we want. We want the open source version, which is free. We'll download it. We don't need the pro version or anything like that. We just need to download the standard one. So we need to install R and then RStudio Desktop. So let's click here. Here's R. R for Mac OS X. R403. The latest release. We want to allow that. It wasn't too big. Right, well that software was installed while we were doing that. So if I type Git now, oh look, we have Git. Alright. So now, we also have R. That's here. So we can install that. Continue, continue, continue. I agree to something. This will take not too much space. Alright. Yeah, we move the installer to the trash. Okay, now we have the R language. And let's download RStudio IDE for Mac as well. So this is the development environment that makes it easier to work with R, more visual. Downloads. There's RStudio. Yes, we just put that in there. Copy it. Alright, and then we can Move that from the drive. Okay, so now we have R and RStudio, and I think we have all the bits we need to get this stuff hooked up. So let's see if we can get them running. Applications. There's RStudio. Yes, we do want to open it. Okay, so we have nothing in the environment. We'll go to Tools, Version Control, Project Setup. We have no active project, so we need to create. We need a new project. Let's try that again. Here we go. Some objects have appeared. Switching to it. There we are. There's all the bits and pieces. And the thing we want is app.r. There it is. And the shiny application. Click on Run App, a button above, which is this button here. It's going to do a bunch of extra installations, I think. Might need to install a few more things. Here we go. Packages required but not installed. So we want to install these packages. It's Shiny, which is the graphical user interface. See if there's any other dependencies. Yep, here's the other packages we need to collapse. So these are, you see the different libraries we have here. Shiny's user interface, Leaflet does mapping, why it's called Leaflet. Data tables, collapse is used to do subsampling. It's just used to load a file. Stream processing, and then the YouTube video thing is done using this video embedding tool. It's all working with no errors, which is nice. This is a freshly installed Mac OS, the latest version, Big Sur 11.1, on a relatively old Mac, 2015 Mac. So try and run it. There we go. This is the application. Need a bigger window. In fact, let's make the window bigger here. Screen. Space, there we go. I'm going to scale this to be more space. That's better. Right, now I can load a file, and in Documents we have the project, and there's an example. We should load the telemetry file. And there we are. Okay, so to make it work in a browser, where it says Run App here, we pop this open. We actually want to run external in the system's default web browser. Now when we start this, it starts Safari in my case, and I have my user interface here, and I can make it a bit smaller. That's Shift Command minus. Kind of shrink the size to get a bit more on the screen. That looks a bit better. Now when I hit Load Local File, it'll take me to the directory that I went to last. If you want to go to a different directory, you pop this open, go back home or to the home of the disk and go find your way back in. The up button won't work because it's just in this one directory here. So we're going to double click on telemetry. Loads it in. We can zoom in here and see the different corners. This is a corkscrew. This little markers here, that's one of the other of the three files that we saw when we came in. One of them marks the turns, the other one is the metadata. So here's the metadata. So this is the file that we loaded from. This is the metadata. It was my first time out of the track. There's a YouTube ID here, which maps to a YouTube video that was taken by the Tesla as it was running around the track. And there's a whole bunch of other information. This is the track mode settings, which are defaults, which track I was at. And I put number of passengers here because your car's heavier if you've got more passengers in it. And then a few other things about what the temperature was like, who organized the trip, what kind of session it was, and then a bunch of information about the car. Mine's a 2020, so I have this set up. I've got 2021 and some of the other options in there, and any of the other things that you've tweaked on the car. Mine's old stock. If you hit this button, it will save a new file to the same directory that the file was loaded from, that has the time in a cumulative form, because the default one resets the time at the beginning of every lap. If you're trying to import this file to other tools, you want to have a continuous time. The other thing it does is add 4 columns for pounds per square inch for pressure instead of bar, so it lets you do PSI a little bit more easily to see what's going on with your tire pressures. So it writes in that format, click that button, import it to some rendering tool. The other thing is taken from metadata is this information here, and then some about which maps are being mapped. It's only got 4 because we've only selected one. Down here, these are all the laps that were in the session. They're sorted in order of the time, so this was the fastest lap. They're all roughly 2 minutes in this case because I was following a car around and wasn't pushing too hard. I've had about 10 seconds or so faster a lap when I've had to clear air and a bit on another session later. So if we look at these ones, let's look at lap 11. Now here I've got 4, 5 and 11. Let's put it on 5. Okay, basically what we have here is, if we zoom in, blue means we're braking, and there's a little pop-up here, 34 miles an hour, 0.61 G, and then accelerating through the corkscrew, you get sort of minus 0.8 G, 50 miles an hour, something like that. And down here, this is the start-finish straight, and I was doing 102 miles an hour as I came into turn 1, which is this bend here. Turn 2 is the hairpin. So that's basically it. where do we do maximum g-force? It's usually somewhere around here. Anyway, so for each lap, we have the maximum miles per hour we did on that lap, the maximum horsepower that the engine generated, converted from the kilowatts, lateral and braking G. This is the amount of the lap, the percentage of the lap that was on a maximum throttle. So if your foot's flat out for 18% of the lap, you get 18 here. Because I was cruising a fair amount, it's not very high. Average kilowatts across the whole lap. So obviously if you're putting more power down, that will be higher. And then the start charge. The percentage of charge level at the beginning of the lap. You can see it was using about 4 or 5% per lap as we went through. And this lap at the end was 37%. So here we have 3 tabs on this side, and other than this metadata, if I hit save, if I edit any of this and hit save, it rewrites the metadata file and puts the file name here. So I can just click here and it rewrites, tells me the file name that it's written to. Uses the same information in the file name, just with the word metadata instead of telemetry. If you save over here, it puts the word render in. Then we can look at temperature. Because I've got 3 of them selected from the master list here, I get 3 different laps shown here. There's 4, there's 5, and there's 11. And you can see that the first 4 and 5 were green. This shows that we were orange, which is getting quite hot, 0.97. Here we hit over 100% battery temperature. 1.02 is the data that Tesla provides. So we've got all that, and then basically I backed off as we were going up the hill this is climbing to the corkscrew, and managed to cool it off a little bit. Information here: the start charge, the brake temperature, front inverter, rear inverter, battery, and also how smoothly you're driving. What's the maximum steering rate? How fast are you turning? Just threw that in. And then you've got seconds and minutes, obviously the same thing. Max mile per hour, kilowatts, which matches the same thing as BHP over here. There's a whole lot of data, and it's fairly easy to change what's in these columns if you want to. Minimum kilowatts, in this case on regen I was putting 100 kilowatts back into the battery. If you want to preserve your battery temperature and you've got good brakes, upgraded brakes, you can set an option to turn regen down so that you put less energy back into the battery. And that can help prevent it overheating. Then some more g-forces. So this is where it gets interesting though. If we go to plots, and I'll hit pause on this for now. Get rid of that. So what we have here is, because I had a YouTube code in the metadata, it pulled up a YouTube video. And because I previously saved a bunch of turns data, that's been loaded in from a file. There were 3 files, remember: metadata, the original file, and the turns data. This is the turns data. And each of these turns is marked on the map with a circle. You can kind of see the little circles here if I zoom in. All right. There's turn 9. This is the corkscrew. And basically what I've done is selected a period that I think I'm interested in. And the way we do that is by doing something like this. We move this and we say, what's it like going into this corner here? This is the corkscrew. So we're going into the corkscrew. There's the corkscrew, following this nice 911 that I was trundling around behind most of this trip. You can see over here, it's coloured in yellow for the area that I'm sliding this around on. So unfortunately it redraws the whole thing each time I do it, but at least you can see which piece of the track each corner is. And then the data is being used to set the start position. It just restarts the video each time it does that. So the start time and offset are basically being manipulated by me sliding this around on here. And this is the speed. There's another one, so you can see 2 different laps. And the map to lap here is number 5, so that is actually the video. See, we've got the start time for lap 5. If I want to watch lap 11, I can watch it on here. And if I want to see the corkscrew, I can click over here, and it will show the corkscrew on lap 11. I was letting people by because I was trying to cool my battery off. I want to see the hairpin, I can click here. Right, so that's pretty much it. This you can add other data, which doesn't make much sense because you can't see it all at once, but you can see I've now got power and lateral acceleration. If I hit reset axis though, it'll do that. And you can also zoom out, and then, if I want to sort of do it without overlapping there, then I can do that and double click and it'll take me in. If you want to zoom into a particular part, you can double click. It'll zoom into that particular part of the track. Okay? Get rid of these, it'll just remove lines. So that's pretty much everything it does. To say the key thing here, the metadata, YouTube ID tells it where to get YouTube, and this particular video I uploaded was the Tesla car generated video, which timing starts the same as the telemetry file, so I have 0 as the start time offset. Now if I have another GoPro video or I edit out the boring part at the beginning where I was just sitting in the pits, then the video start time offset, you put this in here, it's saved with the data, and then it will always start at the right point in the video. And then in this plot, in this side, these are calculated, these are generated by which lap you're in. See, lap 11 is there. If I do lap 5, it changes the start time. If I do lap 4, it changes the start time. And if I click on this, it's changing the offset within the lap. It's just to the second, and so, you want to be kind of, I set these up to be roughly at the breaking point for each lap. So that's it. If anyone is interested in downloading it, playing with it, that would be fine. If you want to edit it and do something different, basically you can come here, hit stop. It saves some of the data for you so you can go and look at it and do your own interactive analysis. There's lots of comments in here, and if you want to edit it and change things, go ahead and try playing around with it. So it's all written in this language called R, which is not terribly well known, but and if somebody wants some particular things to look at, then the other thing they can do, if you want something, you can sort of try asking me. So if we go to github.com/rs-tesla-telemetry, it went to the wiki. Right. Here's the thing. Here's all the data. You can hit issues if you want to record something. New issue, type something in. I'll see that it'll be stored with the project. Okay. And there's some descriptions and some screenshots here. And there's the code itself is here, so you can go look at that without downloading it and running it. There's some documentation in the wiki here. Not a huge amount yet, but something about how the code works. I'm going to add more to that as people get more interested in it. And then the installation information, which I've just recorded this video, so I'm going to update this to match what's in the video and put a link to this video in the installation file, so I haven't quite done that yet. Okay, so that's it.